the National Aeronautics and Space Administration operates the Curiosity rover, which recently identified a diverse mixture of organic molecules embedded within the Martian soil. These specific chemical structures serve as the fundamental building blocks for the origin of life on Earth, and their presence on Mars is completely unprecedented. Currently, researchers cannot determine the exact origin of these compounds. Furthermore, this discovery presents a profound scientific paradox. If these essential components exist, why does the planetary surface remain an entirely sterile environment? The resolution to this anomaly does not appear to reside in the ground, but rather in the atmospheric conditions. Data collected over 45 months by the Perseverance rover revealed 55 distinct acoustic anomalies. These audio recordings indicate atmospheric electrostatic discharges during dust storms, a phenomenon that fundamentally alters our comprehension of Martian chemistry and its capacity to sustain life. The surface of the red planet presents itself as a profoundly desolate environment, appearing from orbit as a silent graveyard. It is a vast, intimidating expanse, dominated entirely by jagged rocks, towering impact craters, and endless stretches of freezing sand. For countless generations, humanity gazed at this rust-colored world and saw nothing but a completely dead, static wasteland. There is no sound of rushing water, no rustling of foliage, and absolutely no macroscopic signs of life to be observed by any conventional instruments. However, beneath this seemingly dead exterior, a monumental event occurred. The National Aeronautics and Space Administration successfully landed the Curiosity rover in the Gale Crater region to conduct extensive geological surveys. Operating tirelessly, this remarkable robotic explorer utilized its highly advanced drill to penetrate deep into the ancient sedimentary rock layers. Deep within this alien dirt, the rover performed detailed chemical analyses on the isotopes it collected. What the Curiosity rover unearthed was something that completely shattered previous scientific expectations. It discovered a highly diverse mixture of organic molecules buried within the harsh, irradiated Martian soil. To comprehend the gravity of this historic discovery, one must look at it strictly through the lens of planetary chemistry. In this specific scientific context, the term organic does not equate to breathing, living organisms currently traversing the planetary surface. Rather, it refers to the hidden architectures of life. Specifically, these organic molecules are highly complex chemical combinations consisting primarily of carbon, hydrogen, and oxygen. These specific chemical structures serve as the exact, fundamental building blocks that are absolutely required for the origin of life to occur, exactly as they functioned on our own planet Earth. Finding these essential components preserved within such a barren and hostile planetary environment is a staggering scientific revelation. Yet, this profound discovery is actively defying our absolute understanding of the Martian environment. The most brilliant scientific minds in the world are currently completely baffled by this data. Despite having access to an immense amount of telemetry reports and chemical analyses, researchers cannot determine the exact origin of these complex compounds. They are faced with a multitude of unanswered questions. How long have these fragile structures existed inside the toxic, irradiated dust? Did they form locally billions of years ago when the planet might have hosted vast oceans of liquid water? Or were they delivered to the surface by ancient cosmic collisions involving meteorites and passing comets during the early stages of our solar system? The data fundamentally confirms their existence, but their true origins remain shrouded in complete mystery. But what no one expected was that the real threat to these molecules wasn't the freezing cold. It was something invisible, hiding in the dust. To fully comprehend the sterile nature of the Martian surface, we must shift our analytical focus thousands of miles away from Gale Crater to the desolate expanse of Jezero Crater, the current operational domain of the Perseverance rover. From a strict engineering perspective, the Perseverance rover was absolutely not constructed or calibrated to record meteorological audio phenomena. One of its most sophisticated analytical tools is the SuperCam instrument. The primary function of the SuperCam is to utilize a high-powered laser beam to vaporize microscopic portions of designated rock targets. Simultaneously, a highly sensitive microphone records the acoustic shock wave generated by the laser impact. By carefully analyzing the specific acoustic signature of the snapping sound, scientists can accurately determine the mass and structural hardness of the Martian geology. It is a brilliant geological tool, entirely focused on analyzing solid matter. However, the scientific method frequently relies on serendipitous observations, and the thin atmosphere of this seemingly dead planet had other plans. While meticulously reviewing the audio telemetry transmitted back to Earth, researchers detected something entirely unexpected. Hidden beneath the mechanical whirs of the rover and the sharp snaps of the laser, there was a chilling crackle. In the strict realm of planetary acoustics, this was a profound acoustic anomaly. The recorded sound did not match any known mechanical operation of the rover. Nor did it correspond to the expected acoustic profile of the ambient Martian winds. For the mission scientists, it initially appeared to be data that shouldn't exist. Driven by this unexplained variable, a dedicated team of planetary scientists initiated a rigorous investigation. They exhaustively sifted through 45 months of continuous audio data captured by the SuperCam microphone. Through this painstaking acoustic analysis, requiring extensive computational processing, they successfully identified exactly 55 distinct instances of these mysterious popping sounds. As they cross-referenced the audio timestamps with the rover's meteorological sensors, a clear and undeniable pattern emerged. These 55 distinct acoustic events only occurred when massive dust storms, or towering dust devils, swept directly over the operational area of the rover. This critical correlation completely changed the trajectory of the investigation. The researchers conclusively determined that these sounds were not the result of physical impacts, such as grains of sand striking the microphone housing, or the crunching of rocks beneath the heavy metallic wheels. Instead, the microphone was capturing the audio signature of electrostatic discharge. As billions of microscopic, desiccated dust particles aggressively collide within the swirling vortex of a massive Martian storm, they undergo severe triboelectric charging. They constantly exchange electrons, rapidly building up a massive static electrical charge across the thin atmospheric layers. When the electrical potential difference becomes too extreme to be contained, it forcefully discharges into the surrounding environment. The microphone was actually recording the localized shock waves of these miniature static lightning strikes. The resulting electrical discharges create a highly volatile and intensely electrified environment, transforming a standard meteorological event into a cosmic horror show of atmospheric friction. To truly comprehend the profound implications of the acoustic anomalies recorded on the surface, we must elevate our scientific perspective. We must transition our focus away from the isolated, ground-based vantage point of the Perseverance rover and shift our analytical gaze upward to the haunting panorama of the Martian orbit. High above the chaotic and unforgiving terrain, the National Aeronautics and Space Administration operates a highly advanced orbital laboratory known as the Mars Atmosphere and Volatile Evolution spacecraft. For years, this satellite has silently monitored the tenuous upper layers of the Martian atmosphere, tracking the gradual loss of atmospheric gases into the vacuum of space. However, during routine operations in February of the year 2026, the highly sensitive plasma wave instrumentation aboard the orbital spacecraft inadvertently captured a highly specific and entirely unexpected electromagnetic pulse. In the precise terminology of atmospheric physics and radio astronomy, this specific frequency pattern is scientifically classified as a Whistler wave. To explain this phenomenon systematically, a Whistler wave is a very low-frequency electromagnetic radio emission that propagates along planetary magnetic field lines. Crucially, within the strictly established parameters of planetary science, Whistler waves are universally recognized as the unmistakable, characteristic radio signatures generated by the sudden, massive discharge of electrical energy. In other words, they represent the absolute, definitive orbital proof of active lightning strikes occurring deep within a planetary atmosphere. The most remarkable aspect of this specific orbital detection was its incredibly brief duration. The primary Whistler wave captured by the spacecraft lasted for a mere 0.4 seconds before completely dissipating into the silent cosmic void. Yet, within the rigorous framework of the scientific method, this fleeting duration does not diminish its monumental significance. The profound twist lies in the correlation of multiple independent data streams across vast distances. Despite its extremely brief existence of just 0.4 seconds, this isolated radio signal stands as irrefutable, ironclad evidence. When meticulously analyzed and synchronized with the ground-based telemetry, this orbital pulse perfectly matches the 55 distinct acoustic crackling sounds previously recorded by the microphone on the Perseverance rover. This flawless alignment of orbital electromagnetic data with ground-level acoustic data shatters our previous assumptions about the dead planet. Mars does, indeed, possess active electrostatic lightning. This is not the familiar lightning born from dense water vapor clouds and precipitation that we constantly observe on our home planet Earth. Instead, it is a much more insidious and invisible phenomenon, violently generated by the relentless kinetic friction and high-speed collision of billions upon billions of dry, highly charged dust particles swirling within colossal atmospheric vortices. Picture yourself standing alone on a desolate red dune, watching a 10-mile-high dust wall rapidly approaching, knowing the very air itself is becoming intensely electrified. Drop your thoughts in the comments. Am I the only one who finds this deeply unsettling? To fully grasp the magnitude of this discovery, we must transition our understanding from a mere dry physical phenomenon into what is effectively a veritable death sentence for any potential biology. When we think of electrical storms, our minds naturally conjure images of the colossal, branching lightning bolts that streak dramatically across the sky of our own planet Earth, followed by the deafening roar of thunder and torrential rain. However, the electrostatic discharges occurring on the red planet are fundamentally different in both their visual scale and their intrinsic nature. These Martian lightning strikes do not resemble the massive luminous arcs we observe during terrestrial thunderstorms. Instead, they manifest as miniature, highly localized sparks of static electricity, flickering invisibly within the chaotic darkness of towering dust devils. Yet, one must absolutely not underestimate their destructive capability based solely on their diminutive size. While they may be very small, they are also extremely aggressive. The energy released by this constant, crackling electrostatic lightning is profound and carries devastating chemical consequences for the entire planetary ecosystem. As billions upon billions of desiccated dust particles collide and rapidly discharge their static electricity, The sheer kinetic and electrical energy involved is more than enough to violently tear apart atmospheric molecules, when the relatively stable gases present in the thin Martian atmosphere, such as carbon dioxide and trace amounts of water vapor, are subjected to this relentless electrical bombardment, their fundamental molecular bonds are completely shattered. The fragmented atoms are then forced by the extreme environment to recombine into new, highly reactive configurations. This continuous atmospheric friction acts as a massive planet-wide chemical factory, independently creating extremely potent oxidizing chemicals. Chief among these newly synthesized, highly reactive compounds are hydrogen peroxide and perchlorate. In a controlled laboratory setting, these specific chemicals are universally recognized as exceedingly powerful oxidants, which are substances that eagerly strip electrons from other molecules, fundamentally altering or entirely destroying them in the rapid process. This brings us directly to the core of the planetary mystery, and the horrifying truth is finally revealed. This is the definitive answer to the biological paradox that has baffled the scientific community since the Curiosity rover first unearthed those complex organic compounds buried in the Gale crater. These highly reactive oxidizing agents do not simply remain inertly suspended in the atmosphere. They precipitate and settle deeply into the Martian soil. They act exactly like invisible acids, continuously bathing the surface of Mars every single day in a toxic coating. When these potent oxidants inevitably encounter the fragile carbon-based chains of the organic molecules, the very same structures we identify as the essential precursors to biology, they immediately begin to dismantle them at an atomic level. It is a merciless chemical bath, systematically and ruthlessly tearing apart the building blocks of life before they ever have the slimmest chance to evolve, replicate, or organize into something more complex. Ultimately, this profound revelation forces the scientific community to completely reevaluate our foundational understanding of planetary habitability. We can no longer view the red planet merely as a world that lost its dense atmosphere and flowing oceans billions of years ago, quietly fading into a dormant state of eternal preservation. The surface of Mars did not die naturally, nor is it simply resting in peace. Rather, it is subjected to an ongoing, extraordinarily violent process of chemical eradication. The planet is constantly being sterilized by its own extreme climate. The swirling dust storms and their hidden electrical furies ensure that the uppermost layers of the soil remain a naturally sterilized graveyard, utterly and perpetually hostile to the delicate chemistry required for any form of life to flourish. To truly understand the devastating scale of this Martian environment, we must shift our analytical focus away from the microscopic realm of oxidized molecules and look toward the macroscopic scale of humanity's billion-dollar machines. The relentless electrostatic forces generated within these planetary dust storms do not merely act as an agent of biological eradication. They fundamentally alter the physical behavior of the particulate matter itself. As the silicate dust grains become highly charged through continuous atmospheric friction, they essentially transform into mechanical pathogens that aggressively cling to absolutely any available surface. This is not merely a theoretical hypothesis. It is a rigorously documented operational reality. We must critically recall the prolonged operational tragedy of the National Aeronautics and Space Administration's InSight lander. This highly sophisticated geophysical laboratory was not destroyed by a catastrophic meteorite impact or a sudden structural failure. Instead, it was systematically trapped and suffocated by this electrostatic dust. The electrically charged particles relentlessly adhered to its extensive solar arrays, stubbornly resisting all natural aerodynamic forces that might have cleared them away. Day after day, the microscopic layers of dust accumulated, steadily draining the lander's vital solar energy reserves until the machine was forced to slowly fade away into the freezing cold solitude of the desolate Martian plains. When viewed through the lens of planetary exploration history, the landscape of the Red Planet is quite literally paved with coffins of our greatest machines. This terrifying realization immediately introduces a profound level of tension regarding the immediate future of human space exploration. At this very moment, the Space Exploration Technologies Corporation is actively developing and planning to launch its colossal Starship spacecraft directly into this deeply hostile environment. Concurrently, the National Aeronautics and Space Administration maintains steadfast ambitions to send the very first human explorers to the Martian surface immediately following the completion of the Artemis lunar program. For many decades, aerospace engineers and mission planners operated under the logical assumption that the most formidable challenges to human survival would be the severe depletion of atmospheric oxygen or the freezing extremes of interplanetary FAVL temperatures. However, the empirical physical data has exposed a fatal flaw in our grand designs. The most immediate threat to human life and operational sustainability is not the lack of breathable air or the bitter cold. The true adversary is an invisible killer. These pervasive electromagnetic dust particles pose an unprecedented engineering crisis. When astronauts finally step onto the rust-colored soil, this highly charged regolith will aggressively adhere to the synthetic fabrics of their pressurized extravehicular spacesuits. It will be inevitably tracked into the pressurized living habitats, where it threatens to ruthlessly infiltrate and permanently clog the delicate microscopic membranes of vital air filtration systems. It will relentlessly grind down the fine mechanical joints of critical infrastructure and systematically coat the essential energy-gathering solar panels and battery systems. We are preparing to send human beings to a world where the very dust beneath their boots is electrically charged and actively engineered by the climate to dismantle their life-saving technology piece by piece. Let us pause for a moment and carefully consider the immense gravity of these environmental parameters. As we synthesize this data, the atmosphere of our inquiry becomes far more somber. We must acknowledge the absolute finality of the surface conditions. It is now a chemical and physical certainty that delicate biological frameworks simply cannot cling to the surface of this planet. The continuous barrage of electrostatic radiation, combined with the relentless, pervasive saturation of highly reactive oxidizers, guarantees that the uppermost layers of the Martian crust will forever remain utterly barren. We must accept this harsh, undeniable reality. The surface is unequivocally hostile to biology. However, the scientific endeavor is intrinsically defined by its ability to adapt to new paradigms. While the surface offers only desolation, our orbital ground-penetrating radar instruments and advanced thermodynamic models indicate a profoundly different environment just a few meters below. Shielded by a thick, heavy crust of insulating rock, the deep underground environment is entirely protected from the destructive atmospheric chemistry and the extreme temperature fluctuations. Down in the absolute, silent darkness, far away from the toxic perchlorates and the violently sparking dust storms, extensive underground ice lakes and completely undisturbed ancient sediments are still being perfectly preserved. These hidden geological layers represent a subterranean sanctuary. They are pristine, sealed vaults holding the planetary history exactly as it was billions of years ago, before the atmosphere thinned and the surface turned toxic. This realization fundamentally shifts our entire strategic approach to astrobiology. To find definitive evidence of life, human engineering will have to adapt to an entirely new challenge. Future robotic platforms and eventual human explorers will have to deploy highly sophisticated technology to drill deep into the crust. The hunt for extraterrestrial life is absolutely not over. Rather, It has only just shifted its direction vertically. This profound revelation transforms our previous tension into a renewed sense of scientific hope. The magnificent robotic emissaries we have sent thus far have merely scratched the outermost sterilized skin of the planet. Beneath the scars of a violent world, a silent, protected environment could still be patiently waiting for our discovery. As we begin to design the next generation of deep drilling mechanisms, we finally understand that all our previous decades of exploration were merely a preliminary survey. The terrifying truth of the surface climate does not signify the end of our grand quest. Instead, it illuminates the true path forward, proving beyond any doubt that the real search hasn't even begun. As we step back to synthesize this vast amount of planetary data, we must fundamentally alter our cosmic perspective. We began this scientific journey by unearthing the fragile organic building blocks of life, only to trace their inevitable destruction back to the invisible, crackling furies of electrostatic dust storms and relentless chemical oxidation. For generations, humanity peered through telescopes and guided robotic emissaries across what we believed to be a static, frozen wasteland. We looked at Mars and thought it was simply dead. We were wrong. It is actively killing. Yet, as a scientist observing the raw, uncompromising mechanics of the cosmos, I do not view this profound revelation as a reason for despair. This violent atmospheric chemistry is not an act of celestial malice. It is merely a complex manifestation of physical parameters we had not yet fully accounted for. The universe isn't broken. Our map of it is just incomplete. Every catastrophic mission anomaly and every single fallen machine buried beneath the red sands is not a final defeat. These are the essential, inevitable stepping stones we must traverse to truly understand the profound laws of creation. By forcing our scientific instruments to look deeper, literally beneath the sterilized surface, this hostile world is actively teaching us exactly what is required to survive the vastness of space. As we continue to adapt our engineering and push the boundaries of astrobiology into the subterranean unknown, I leave you with a final inquiry to consider. What do you think? Does this realization make the universe feel more terrifying or more deeply connected to us? Thank you so much for watching. The universe is full of terrifying and beautiful mysteries, and exploring them together is what makes this journey so incredible. If you enjoyed this deep dive into Mars, please subscribe and leave a comment below. I will keep exploring. See you all next time.